Mhm.
Welcome to Go Green Radio, everybody. I'm so glad that you could join us today because our guest is Raj Setty. He is the president of Setty and Associates. They're a full service mechanical, electrical, and plumbing consulting engineering firm. They're headquartered in DC, but they have 10 offices all over the place, and they specialize in institutional projects. And we're going to be talking about how they take their craft, their knowledge, their expertise, and deliver healthy, high performing buildings for their clients. And Raj, I am just so excited to have you on Go Green Radio. Welcome to the show.
Thank you, Jill. Okay, I'm very excited to be here too.
You and I met during a virtual meeting of an organization called the State Clean Indoor Air Collaborative, and that's convened by our good friend Dr. Georgia Lagudis, who is a senior fellow at the Brown University Pandemic Center. And I'd love for you to tell us just a little bit about your work with Dr. Lagudis.
So I think it's been good. It's a very small community, and it's nice to see some engineers starting to get into discussions with a lot of these researchers. They've done such good work over the past, I would say, decade, and then it started to increase over the pandemic. What I like to always frame it as, there's any problem, there's three legs to the solution. There's an engineering leg, there's a political leg, and a financial leg. And the researchers have done a really good job of doing the research, and now it's in the purview of engineers to kind of implement. Politically, that's where Georgia has done a really good job of raising awareness, and then you always need funding. So that's kind of where I'm happy she reached out, and we're complementary to that progression to finally get things done.
Well, your firm specializes in indoor air quality, and I want to spend some time talking about some of the services that you provide. Your website refers to advanced indoor air quality. And for our listeners who may not be familiar with indoor air quality issues, help us understand what that means.
So there's a lot of different places to think about air. And of course, ventilation is the biggest one that everyone knows, and now there's filtration. But in the great scheme of things, those are your two main levers: more outside air and then more recirculation across filters. And then, of course, you can go into the minutia of different filter types and how much fresh air and quantity. So when we think of advanced air quality in our guideline, I'm also a chair of ASHRAE TC 9.7 educational facilities. What we see from the marketplace is just how to make those decisions. What do I buy? How do I run it? Where do I deploy it? And so we're trying to just give more of a common sense framework that can be traced back to how do I begin and start? And that's why we built this advanced indoor air quality frameworks. It's almost a checklist, which as engineers, we love checklists. And then we kind of go through and like, what are the trade-offs? So we're all have the same intent, which is to improve the indoor air quality within these classrooms and schools, but we also need to look at it as one large contiguous body, the school. So often the guidance that you'll see out there is really about the classroom, but doesn't address gyms, bathrooms, assembly spaces, corridors. So we want to be very holistic about that because that's how the buildings are.
And locker rooms. I'll tell you, one of the biggest
Locker
indoor air
room.
quality problems I've ever seen in a school district was in the locker room and the humidity and all those issues. Now, your organization, your firm, and my nonprofit organization share a common thread, and that is we geek out over data. And this week, my staff and I were really geeking out over a tool that you have on your website called the IAQ Risk Estimator. And I
Right.
want to give everybody the website address so that if there are other data geeks out there, you can take a look. You can find it at www.seti, that's SETTY.com/, indoor dash air dot dash quality. Spend a little time, Raj, talking about that tool and how you use it to help building owners achieve their indoor air quality goals.
Right. Yes. So the basis of any engineering is going to be a set of calculations. And so there's what's called the Wells-Riley calculation. where you have the different variables, airflow, particulate, count, temperatures, all those small filtration, all those small parameters that ultimately we wanted to put into a tool where you could adjust the levers and then that it doesn't reduce or eliminate any kind of viruses or things like that, but it gives us a framework for the reduction in probability. We're always going to say the word probability. So if we put in 50 air cleaners in a room, one next to each student, that probably is going to be a pretty good reduction in transmission. So that's kind of what we built it on. You can't do that. So then what are these different levers? The most important piece with any kind of tool is just it's a model that does give practitioners, engineers, just that a few decision points to base against each other. And I think that's what it is. It's not just go into a classroom and throw this in, but let's model what the classroom has, see if we can adjust any of the operating times, things like that, or change the filters. And then we start to add new cost items. Again, a common sense thing. Maybe we can just open all the windows and, what's the ideal classroom? One sitting outside under the trees. That would be what I'd want for my kids. So that's kind of where we put the tool. There was always a lot of panic. Let's just dump sensors and do this and do this. And so we're like, okay, maybe you don't need that. Like the art rooms, we saw a very different need than you would in just a standard classroom. So that's where you need to have some quantification, not just sensors, but quantification of what those tools are, those pieces of equipment, how they're operating to reach those numbers.
I love the way that your firm is not only data centric, but also tech forward. And I'd love for you to talk to us about how you use Cyclops um, and how this helps with your data management for your clients' needs.
So if anyone has renovated their house, and I'm sure many of you have, you also understand how kind of complicated and broken that whole system is. So in my basement, I have 70 paint cans. I have a drawer full of O&M manuals. So that now imagine that scale on a classroom or a school system. Thousands and thousands of distributed, siloed, disconnected documents. So with something like Cyclops, it's a what we call a digital twin, where we bring in all these siloed pieces of information and at least correlate them. So let's say you have your IAQ sensor that says we have a spike in CO2. Now, what happens in the real world, then an operator has to take that spike that's been sustained, let's say for 4 hours, then they have to go to their building automation system, find the particular air handling unit that serves that classroom. In a school, it might be 40, 50 air handlers at times or 5 air handlers, and then make the adjustments to that air handler on the outside air. And then that takes time to kind of run it through. The reality is it doesn't always happen that way, right? Because you have these two different software packages.
Mhm.
So what we're trying to do is bring those into a single pane of glass where you can correlate all those. So hopefully that makes sense. That's operations. And then imagine if the damper on that unit is broken. So now we know that the fix is we need a new part. So think about how long that part's going to take to find. So we bring in the manuals, the model numbers, and now we're using a language model to help triage that quicker. So the data spikes that you'll see on sensors are your first step. But what we are singularly focused on is solve it, make it go away. Data is great, but you need the plan to make it all back to baseline.
I would imagine, Raj, just as a follow-up to that, that school district employees might need some training on that because I've worked with facilities staff in school districts all over the country for over 20 years, and I haven't seen a lot of this level of building management. Is that something that your firm provides as well, or do you guys come in as the project managers and do it for a school district or another client in another
So
industry?
We'll do both. At this point, good engineers will hand over their designs, hand over their solutions, and become true consultants and walk the engineers who are on site, the building operators. I use the term engineers on site loosely. So
Hmm.
the building operators to figure out how to run these. I mean, everyone knows like when you get new software packages, they're not as elegant as an Apple iPhone. They are clunky, they're hard to figure out. So just throwing out a new software package is not the goal. It's really focus on what the outcome is. So what is the outcome that they want? We want to go into their workflow. I mean, they've been doing it for years right now, but we want to now give them better triage. So let's say we're in California and then all of a sudden you have some spikes in particulate. Like me as an engineer immediately knows maybe there's wildfire smoke because that's the introduction into the building. So do they know quickly shut the outside air dampers, right? That's how you mitigate it. And that's where I think within the platform, you can ask those questions and there's language models that are trained on an engineer's mindset to help give them some of those solutions.
Your firm has a lot of experience working with K through 12 schools, and that's a particular interest of mine, as all my listeners know, because I'm the CEO of a nonprofit called the Go Green Initiative. I've asked this question that I'm about to ask you to all different types of folks who are working on indoor air quality, sometimes public health folks, sometimes school district administrators, educators of different types, but from an engineer's perspective, and not just any engineer, Raj, an engineer who graduated from UC Davis, go Aggies. I want to hear your perspective on this question. How does it benefit students to learn in a healthy, high-performing building?
So there are a lot of research studies about cognitive decline during afternoons and CO2 starts to spike. So over the last, we'll say maybe 3 or 4 decades, a lot of the codes, a lot of the work that ASHRAE has been doing has focused on that exact amount of air turnover. So if you think about outcomes, like, so I used to be a teacher. That's one of the reasons I love schools, even though it was very hard. So I couldn't keep being a teacher. Taught for 2 years, one of the toughest jobs I've ever had. So, what is it that we're trying to achieve with our indoor environment is just making it not a distraction to the learning curriculum, to the learner space. I've worked in a lot of inner city schools, and it's not just the indoor air quality. You've got pipes leaking, you've got lights broken, you've got windows broken. And I think from a societal standpoint, we as a society will deal with that at some point. It's inevitable. So I'd much rather be on the early end of prevention and make sure that they have great spaces to learn in teachers, curriculum, all that's not in my purview. That's plenty of money's going in that. But some of the most, say, impactful work I've seen is a couple schools in DC where they basically were treated as prisons for years. And then the new school came in. One of my favorites is Dunbar High School, treated just as a magnificent glass, airy, light structure. There's, Paul Dunbar was a poet, and there's like this inspirational Nobel laureates who graduated from the school in the front of the school and the library, excuse me. So I think those are the places where, what's our goal? We just want to empower the kids to learn, and our point is the spaces. So when I walk into that space, I know that the test scores have already increased, which is a quantitative result, and air is one, but just treating the schools now as not a prison. Yeah, there's so much of the design used to just be the flat, singular, one level, no windows, um, but more is just beautiful centerpieces of the community. That's why I'm happy to be part of it.
I love it. Well, we're going to take a quick commercial break, but when we come back, we have much more with Raj Setty. So don't go away, folks. There's more Go Green Radio right after this. Welcome back to Go Green Radio, everybody. So glad that you could join us today and so excited to have our guest today. If you just joined us, let me catch you up. Our guest today is Raj Setty. He's the president of Setty and Associates. They have 10 offices all over the world, and they are a full service mechanical, electrical, and plumbing consulting engineering firm. We were talking about indoor air quality. They have a lot of experience in K through 12 schools, but not just in schools, and we'll get to that in just a moment. But staying on K through 12 schools, Raj, talk to us about the importance of taking an indoor air quality baseline and having indoor air quality sensors.
Great question. So, one of the baselines that we recommend and we do, and a lot of legislation is starting to come down, is just figure out what you have first as far as equipment. Once you figure out what equipment you have, how it can be operated, take the example, I'll get to the sensors, but if I have a piece of equipment that cannot bring in any ventilation, any fresh air, well, we know that the sensors are going to always spike during classroom activities for the CO2. So focus on the time, the money, the effort on what you have first. Next, you focus on how it's being operated and maintained. If they don't ever change the filters, I don't necessarily need to put in a sensor. And that also goes to just the level of training or level of protocols of the staff, right? I mean, sometimes we change our oil, sometimes we don't. So real basic rules of engagement on buildings. Preventative maintenance is, what's the adage? An ounce of prevention is worth a pound of cure. So then we have some baseline data. Then we can start to put in the sensors. So some of the large projects we've done, some we put sensors in every classroom, some we put it on every 1,500 square feet. So we just get a sampling. Now, the most important thing is once the sensor data starts coming in, what are you going to do with that? And if you don't have a plan, then don't put the sensors in, because that is the worst thing that can happen is because a building operator gets overwhelmed with 100,000, 200,000 alarms, sensor spikes a day. What's the simplest thing to do is to unplug it. And that's not our intent. So we also need to take all that sensor data, look at it, a spike that goes up for 10 minutes, we can ignore in CO2, a spike that goes up and stays there for 4 hours, then that should be triaged into an alarm. And I think a lot of the sensor companies are very adept at putting in sensors, providing data, but not all data and more data is not always great. It has to get triaged. Do you, Jill, communicate better because of email, or is the happiest thing in your life when you delete an email? And that is what we're trying
I
to
got a
avoid.
quick and easy answer to
So that's kind of what we're
that
trying to avoid. I mean, there's these guys are, and when I say these guys, the folks in the field are overwhelmed with the data amount coming in. A
one.
single sensor with 5 inputs: temperature, humidity, CO2, TVOCs, particulate, sampling every 5 seconds is a tremendous amount of data. One way to
Mhm.
triage it is you put it in a graph. Great. So now I have some spikes. What's the next way to look at it? So I can't look at every sensor in a school. It could be 70 sensors, 100 sensors. I'm not going to be watching those. So that has to go into a computer to kind of read it and then analyze it in the sense of what really matters, what doesn't matter. So that's kind of where some of my frustration is that
Mhm.
because we're not doing a good job of dealing with all that, people are just unplugging them.
Well, and I know that, some of the case studies of success out there in terms of indoor air quality in schools, some of them are very technology heavy, and that was a result of the pandemic. And that is great. But not every school district is in the same predicament. Like, for instance, with Boston Public Schools, they were smart about getting a research partner early on to help interpret some of the data. And they learned a lot along the way. For some of our school districts, I mean, leaning into prevention first,
Mhm.
and like you said, taking those baseline data is so important because you know, it's great if you have the filtration systems to take contaminants out of the air quality, but in the cases where you can, if you never introduce those contaminants in the first place, that's even better. Kind of
Yeah.
back to an ounce of prevention is worth a pound of cure. I would love to talk with you about some of the case studies that you have in K through 12 schools in different locations, different climate zones. And the first one I'd love for you to tell us about is some of the work that you've done in New York City. Tell us about those projects.
So a lot of the work in New York City that we do is with SCA, which is the School Construction Authority. We do a lot of the peer reviews. We're reviewing designs that come across many, many different engineering firms, and we just kind of look and see how they're following the codes. Not everything in indoor air quality is codified at this stage, so there it's all guidelines, best practices. And our job is not to add costs to these projects, but if there's easy, common sense ways to upgrade a filter, increase distribution on the air side, a big piece of what's rarely, it's discussed a lot in the engineering circles is where you're distributing the air. So if you have all this fresh air, do you have a good mechanism to reach every kid in the classroom? But if you're just dumping it into the corner, which is allowed by code, then we know we're not going to get that distribution. And then that goes the same with the return and the exhaust. So if someone sneezes, we want to pick all that up. So part of some of the work in the school authority, we do have a couple new schools that we're designing, is also looking at that level of distribution, and information starts to disseminate into the engineering community, typically through ASHRAE, then codes, and then some of the other standards like well and lead. So we're trying to
Hmm.
help with that. But
You've
engineers
also,
generally, most of them are all trying to do the right thing, but it's narrow um, fields that they've got to comply with. The energy codes,
Mhm.
IAQ, budget, making it
Abs-
fit. So
Absolutely. I mean, we have not found that silver bullet that works for every school district on this. And we will talk about the nexus between indoor air quality and energy consumption in a moment. But I want to go back to a very different, climate area, and that's DC. When I think of DC right now, I know a lot of people are thinking about snow and ice and winter storms, but I think of humidity.
yeah.
And so they have some different challenges with their outdoor air quality that can impact indoor air quality. Talk to us about some of the work you've done in the DC public school district.
Yes, I think the biggest takeaway from a system like DC, you're talking almost 140 to 160 schools across a wide variety of systems and age and maintenance. And so I think when you look at the big portfolios like that, they're buying out services at a portfolio level. They're making decisions at a portfolio level. So consulting with them, that's how we had to look at it. 25 million square feet, not on a singular classroom. So one of the nice things we came out was thinking about a very equitable program on how to spend the money. So they get 35 million. What does equity mean in that context? Does it mean put the most money into where you have the highest risk? So we level set every school. Does it mean do it by square footage equity? Does it mean do it by school where they all get the same money? Or does it mean do it by the number of students? So I think that's something I really learned in that project, is thinking about how to distribute and having that politically defensible situation. Because that was very important for these huge mega school districts. When you work through them, it's okay, why did you do it on the politics side? And so
Hmm.
do you take all that money and put it into the building that has no ventilation? Like those are the decisions.
Yeah, that's tough. I mean, you ask any school board member in America, and these are the kind of conversations that come up at school board meetings, and people show up to give public comment asking why the school across town got something that the school in their
Yeah.
neighborhood didn't get. And so that's, the fact that the engineers have to be involved in those or conversations is really insightful. And
I
tell us
think you hit
about,
it
oh,
on the
go ahead.
head. Like,
Hmm.
just bring the engineers into those conversations, right? A system like
Hmm.
DC has very poor areas or a
Yep.
city and very affluent, all within, that small square footage. So,
Well, and what you said there, Raj, is, you bring the engineers into the conversation, you can help the public policy makers explain in very, objective, data-driven terms why decisions were made. And so
right.
I like that. Um, I'll give you a choice before we go to break to talk about either Atlanta or Prince George's County, in terms of case studies that you'd like to share with us.
So I think Atlanta was pretty interesting. What they really wanted to know was the specific types of equipment in the classroom, how they reacted to actually seeing inert movement. So how did the distribution work? And we work with this great company called Safe Traces, who put an inert DNA, I have to use the right terms, into the airstream. And then we could actually see if it was making it back to the air handler, where we then know we could filter it. And then we can adjust the systems and the distribution of the air to pick those things up because it wasn't all leaving the classroom, right? That's the key. We need to get it out of the classroom, get it filtered, and then get the clean air back. And so that was a nice way to have real tangible data. If you think about a sensor again, it's just stuck in a corner of a classroom. It's 900 square feet. There's a lot of zones that, you know, you have no idea. Just because it's at the front says X amount on particulate doesn't mean the opposite corner is seeing that same kind of profile. So all we know is we need to get the air turned over. And so this is a way in that classroom with what we call equivalent air changes. And that's what we're trying to do.
Well, you mentioned Safe Traces, and the CEO, Eric Malmstrom, is a good friend of both Go Green Radio and the Go Green Initiative, so we'll give him a shout out as well. Safe Traces has our utmost respect, and glad to
Yes.
hear that you guys have been partnering. We're going to take a quick commercial break, but when we come back, we're going to talk about some of the case studies outside of K through 12 schools that Raj and his company, Setty and Associates, have been involved with. So don't go away, folks. There's more Go Green Radio right after this. Welcome back to Go Green Radio. We're so glad that you're with us, and so glad to have Raj Setty with us. He is talking about his firm, Setty and Associates, and some of the work that they are doing to create healthy and high-performing buildings for their clients. And we've been talking about some of the work that you've done in K through 12 schools, which is a personal interest of mine and my organization, the Go Green Initiative. But your company's portfolio reaches far beyond schools. You work with government buildings, hospitals, housing, and so much more. In fact, I even read that you have a current project with Johns Hopkins Health System. And talk about credibility. They don't just choose any vendor. So I would love for you to tell us about your work with Johns Hopkins.
Sure. So there's a couple different sectors to Hopkins. There's the healthcare side, and then there's also the college side. So we have a couple large projects with the college side. There's some new buildings coming up that are pretty exciting. And then on the hospital side, as they expand, they do what we call fit out. So they're always adjusting, upgrading ORs, you name it. So we get pulled into some of those. There's a lot of great engineers out there that they do use, especially on the central plants and things like that. So we've been fortunate enough on our healthcare division to get some of that work.
And how do you partner with an organization like that in the healthcare industry? I mean, they're known as being cutting edge. Um, do you interface with the same types of folks that you would like in a K through 12 setting, like the facilities folks, or are you also working with some of the healthcare professionals as well?
So, like all good engineering answers, it depends. So, often we do get brought in by different architects who do have the relationships. Architects generally have to work with the programming, thinking about what the space is going to be used, the turnover. And so then they start to hire the consultants under that. When we do work generally directly with the hospital, it's often with their facilities department. We have a commissioning group, forensic engineering group that goes in and starts to figure out what's gone wrong, how to optimize. Those are a lot of times we get pulled in directly um, to the hospital systems through the facility groups.
hmm Now, I noticed on your website,
Hmm,
which I love, by the way,
thank
Setty.com,
you.
Setty.com. Yeah, it's got a lot of great, you can information snack all day on your website. It's good stuff. So I highly
You're one
recommend.
of the 9 people that visited it today. Good.
Maybe we can help with that. So I saw that you also have some work with some federal agencies. And so I saw USDA, I saw Department of Energy, and the Social Security Administration. Say that three times fast.
Yes.
Talk to us about some of those projects, Raj.
So what we, excel at the company are just the larger scale, more complicated projects. And when I say complicated, it's about the systems. USDA does a lot of labs and testing. Scenarios. So we did a huge lab out in Salinas, California, where they're just bringing in a lot of the different produce and things and testing it and seeing what new pesticides are out there and trying to keep up with, the private industry. So with those labs, they have massive greenhouses, they have, fume hoods. They're really trying to look at what can become airborne, what's not. So with the federal government, often it's not just the office buildings here in the DC area, but they have, we do a lot of work with, we used to do work, we're going to get back in with like NIST, Department of Energy. And so these folks in the DC area are very office driven. So those are constantly turnover when there's a new administration or they need to keep up with the new energy codes. But out in the country, then you're looking at forward front buildings, labs, government offices that are everywhere, FBI, you name it. So it's exciting from that standpoint that they do have some pretty cutting edge buildings. Like here in the DC area, we have one of the government agencies has a small nuclear reactor. So when we go there, it's just like you got to be on your game. So that's
I'll
what I love
say.
about the government. Engineers, we're the offensive linemen. No one knows who we are. We just cannot make a mistake, no holding penalties. So that's kind of the excitement.
Oh, we're gonna go there. I'm so glad we can use sports analogies because I'm all about it. I'm all about it.
Good.
Right now, because I'm thinking hockey, I'm like, later today I'm gonna hang up my skates. That's kind of where my head's at. I want to give you a chance to talk about some different areas of expertise within your firm and some of the projects that you've done. And I really want to start with net zero because I think there's a good chance that some of our listeners may be unfamiliar with what a net zero energy building is. And so I'd love to have you explain that to us and then talk about how your firm can help a building owner reach that goal of net zero.
Sure. So there's a few different definitions of net zero. The main one I'm going to focus on is the energy that crosses your site coming in from your utility. You generate the equivalent of that energy across a year, and that's just at a very high level, net zero. Right now, we're seeing a lot more movement also for carbon neutrality. So how that energy comes in. So yes, it could have come in as hydrocarbons, as in the form of natural gas, typically. So what we're trying to balance when you do net zero buildings, the most important thing is to optimize. And what I always try to tell design engineers is just turn things off. There's nothing simpler than that. There's 8760 hours in a year. And we occupy buildings roughly 2 to 3,000 hours. So the easiest place to focus is those other 4 to 5,000 hours. Turn things off. Turn your pumps off, turn your air handlers off, turn all systems to base load. And that's a simple way to become more energy efficiency on your path to net zero. You can always get net zero if you have the space and you overload it with solar panels, but that's not very efficient, nor is it elegant as an engineer. We love efficiency, so we want to drive the usage down. We measure that in BTUs per square foot, and then we want to generate. And then that's kind of that balance. And there are places now where you can buy solar as well, that counts towards that net zero.
Yeah.
Hopefully that makes some sense.
Yeah, renewable energy credits. We did a whole show on
Yep,
that. So we do know that. And kind of going back to the K through 12 scenario, I've worked with a lot of school districts that really want to go net zero and they start by calling a solar vendor. And I'm like, don't start there. They're going to
yeah,
sell you as much as possible because that's in their best interest. But if you can bring your base load down first through some,
that's it.
assessments and energy efficiency work, then call your solar vendor and purchase whatever you're going to do to cover that lower base load that's more efficient. And if you're using public dollars, whether this is schools, hospitals, other publicly funded operations, that's the best way to protect taxpayer investment as well. So
I'll
thank you
give you an
for covering
example
that.
that there's not enough just common sense and talking with the operators of the building, the users. So we had a large high school. I went in and met with the kitchen staff, which was, when we modeled it, that was going to use a bunch of energy. And I go, what do you do? Just talk to me about your menus. They're like, oh, on this day we bring in pizza. This day we cook spaghetti. On this breakfast day, we bring in some outside lunch. Then I go, well, how do you run this kitchen? They go, we walk in 4 or 5 in the morning, we just turn everything on. And then
Oh.
I said, what if we just align the menu to have the stuff you bring in on Thursdays? And so there's one day now where they don't turn everything on. So there's
Hmm.
like simple ways to kind of align that. I hope it's still running, but it didn't change anything, right? They're bringing in pizza from outside and they're bringing in fruit from outside. So on that day, they don't have to turn. We got almost a 15% reduction in kitchen energy.
Yep.
So that is where we need to focus on how people use energy and why should they care?
Hmm. Well, here's one reason, but there are lots
Yeah.
of other reasons as well. But thanks for that, Raj. So, as I was looking at the areas of expertise that your firm holds on your website, little TMI about myself, I watch a lot of crime shows on TV. I don't apologize for that. And so, when I got to expert witness and forensic engineering, naturally, I was interested. So, tell us a little bit more about what that means.
So in the world of forensic engineering, it's often post-evaluation, what went wrong, why did it happen, and how do we stop it? So years ago, I was in probably my biggest forensic engineering project was the whole Federal Triangle was flooded after a big rain event, and hundreds of millions of dollars of damage were done to Justice, Treasury, um, several other buildings. And so the water got up to about 7, 8 feet. And so kind of just looking, why did that happen? Why didn't it discharge to the tidal basin? You have all these different agencies, and then it's 3 levels in that forensic engineering, and it's very interesting for an engineer. It's like, okay, why didn't the water drain? So we worked with a civil to see that there was a small pipe that's never been upgraded, and small in the world of civil and storm is like an 8 foot pipe. The second was there was a barbecue battle the weekend before. They weren't able to clean the streets, so there was a ton of garbage that got piled in there. And then it was a crazy rain event, which we are no longer seeing, 100-year rain events. They're pretty much every 10 years now. And so systems infrastructure is not there. So this is a forensic engineering kind of thought. And then finally, like when the water comes in, why do we put all of our electrical equipment on the basement, which gets flooded, which puts the building out of commission for, you know, years. So now we try to harden the buildings. We call it resiliency and move that critical equipment up as well. So those are the kind of fun forensic engineering because most of it is dealing with aged infrastructure.
That actually does sound really fun. And just because I'd love to watch as you do something like that, I'm just gonna put a plug in for you to like put a GoPro on your on your hat or something. Take us with you next time you do one of those
You don't want to go down
investigations.
some of these sewer tunnels.
You don't know. Maybe we do. Maybe we do.
Yeah, yeah.
So, in speaking about, that instance of a, 100-year flood event, talk to us about, I think it's a perfect segue to talk about your emergency preparedness services.
So as standard temperatures rise over the median, then you're going to get more moisture in the air. And, air is composed of 2 components, just air, nitrogen, oxygen, and then water. So as you have these huge deluge events that are starting to get more common, so emergency preparedness, when we do consult on that is, are your roof drains sized? When I review drawings for my engineers, one of my favorite comments is always, how's this building going to flood? Walk me through when you get an event, what's going to get compromised? When are your pumps going to get overwhelmed? We can't design for every condition. So we just need to know those edge cases and alert the owner like, okay, if you have a rain event of 3 inches, 4 inches, 5 inches an hour, this is where you get compromised. So preparing in my mind is really, can you do an orderly shutdown and bring that building back up after the event? When you have
Hmm.
catastrophic events, you have to rebuild, but can I shut it down before the hurricane? It's like putting wood up on your
Hmm.
windows that protects the window. That's easy enough. Can you shut down your systems to protect them from an event or at least bring everything back online? The
Hmm.
new world of emergency preparedness is also what happens when your IT goes out. Everything is connected, and a lot of big equipment doesn't necessarily start without their building automation system. And if that goes out to the web and that IT data connection gets severed, the equipment needs to run kind of in an island mode. So that just needs to
Hmm.
get programmed and make sure it works that way because it's going to be searching where are my instructions, where are my instructions. Small things like that, as you can kind of think about. It's like
Wow.
your driverless car will just
Hmm.
turn off one day if
Wow,
there's no
Raj, you
IT.
just blew my mind, and now I want to do a whole new show on just that, and we will. Trust me. It's
Okay,
so because I've actually been just reading. I'm exposing a lot of my geeky side on the show, but I've just been reading a
good.
book called Dark Territory
Mm.
about the history of cybersecurity in our country, and so now I want to go down that hole. So anyway, we're going to take a quick commercial break, but when we come back, we have much more with Raj Setty. Don't go away, folks. There's more Go Green Radio right after this. Welcome back to Go Green Radio, everybody. So glad that you could join us today. We're talking with Raj Setty about his engineering firm's suite of services. Get out on his website. It's a treat. If you like buildings, if you want to learn about healthy, high performance buildings, this is the good place to go. Setty.com. It's SETTY.com. Um, Raj, as many of my listeners know, my nonprofit organization has recently received a 5-year grant from the EPA to improve indoor air quality in K through 12 schools throughout the country. In fact, folks, if you're shopping around for websites while you're looking at Raj's site, you can also check out ours at gogreeninitiative.org. And if you do .org/IAQ, you'll see what we're doing in indoor air quality. The most common response that I get when we're talking about some of the offerings that we have through this grant, Raj, is that, you know, I don't have enough funding, our school district doesn't have enough funding to properly address indoor air quality. And I know the same is true for other sectors of building owners. What are your thoughts about how a budget constrained building owner, regardless of the sector, can begin building an indoor air quality management plan?
Yeah, there's no easy answer for the monetary piece, but the way I look at it with especially K through 12 is you have a very motivated, I would say, workforce, which is students. So ultimately, how do you engage them in that? When I went to school, like we would clean the classrooms on Fridays, and that was just kind of what it was. And then it rotated, the corridors and things like that. So now I think about where we are today, and pretty much every single activity is contracted out, everything. So cleaning, cooking, teaching, you name it. So when I think about how do you actually save money, and can one of the kids just have a, home ec or whatever you want to call it, and they help the folks go change filters. And I think as we move into the world of AI and LLM, giving more hands-on real world experience is going to be invaluable. You know, no one really knows what an air handler looks like, much less how to open one out and take that. So what do? We sub it all out. I'm not saying everyone should clean the bathrooms, but I think cleaning their classrooms. So going back to your budget question, the biggest cost is always labor in
Mhm.
any of these IAQ management plans. So labor to install the sensors, labor to monitor the data, labor then to go and change the filters when it says that. So it's the parts and pieces are not that expensive. So I think that's kind of where I would push it. It should all be projects for the school. And indoor air quality is one of them. Energy is another one. Monitor it, and there's real world results. We had one project where I just said, why don't we just put an energy score above every classroom, and all the kids can compete. So he gets the lowest, and then they get $50 off at the bookstore. Fine. It's incentivized. There needs to be the financial incentivization. Otherwise, no one cares. So,
Well, you bring up a great point because, we're hearing more and more emphasis on CTE programs,
yeah.
and, making sure that students know about the opportunities in the trades, knowing, about STEM opportunities, which engineering definitely is. Um, what a great learning lab, your own school
Exactly.
building to learn some of these things. That's cool. That's a great idea.
Good.
Another
Go forward
yeah.
with it.
Um, uh, another comment that I hear a lot from school districts is we don't have the budget to run our HVAC systems night and day to make sure we have perfect indoor air quality. We can't afford a higher energy bill. And there's this perception that in order to have good quality indoor air quality, you've got to run your HVAC nonstop. And so I'd love for you to talk to us about that critical nexus between indoor air quality and energy efficiency.
So, every engineer will tell you the same thing, which is if you run the units longer, it will use more energy. That's pretty much common sense. So, what are we really trying to focus on to save energy will be those unoccupied hours. And as I said before, a lot of times the units are going to be running regardless. when it's occupied to maintain temperature control. That's just a broad stretch. So turn them off on the weekends, set them back. That's where you're going to get your energy efficiency. Um, on the indoor air quality, you'll hear things about the filters are causing a higher pressure drop. Um, the short answer is sometimes you can get a filter that has lower pressure drops, but I would just use common sense. Change it to the higher MERV ratings on the filters. If you start seeing diminished temperature performance or higher energy bills, then go back to the
Mm-hmm.
other filter. I guess where I always go back to is like there's no downside except for operational money in these. And so if Jill, you focus on outcomes. What is your outcome? If it's energy savings, then yes, you need to turn it off. If it's the student's well-being, then you need to increase your focus on indoor air quality. If it's test scores, then you're going to have a different outcome. So what I often see is the singular outcome has to be defined, and then we can kind of work back there with the
Mm-hmm.
solution.
Yep, that makes it sound like good old common sense. And sometimes it just takes somebody like you and your firm to help everybody take a beat. Let's think this through. Let's write things down in terms of a strategic goal that we're trying to reach as we're, working on our systems and our building management. And I really appreciate that.
And it's going to happen. Like this is the long tail of education. There was a time there wasn't a school without a sprinkler system. You can't think of a new one now. It just parts of it is what it is. Does it cost more? Of course. But it's the right thing to do. You do what's right because it's right. Simple as that.
Mhm. Raj, we've come to the point in Go Green Radio where I like to ask personal question. So I hope you're okay with that because many of our listeners are young adults who are early in their careers, some still in college, and they want to be a part of sustainability. They want a green job, and they probably are looking at what you do and thinking, I'd love to do something that impactful. Um, but they're often anxious about what career path or educational career path they should take. Should I study, engineering? I'm really good at writing, or I really, favor accounting. What should I study, if I really want to make an impact in sustainability and have a green job? And based on your own experience at the University of California, Davis, and, talking with so many other professionals in the field, what advice would you give them?
So I went into Davis with a forestry major, and then I thought about what that impact was going to be. I wanted to be out in the woods, sustainable career, but ultimately I realized I'd just be working for a logging company. You know, you can cut this tree, you can't cut that tree. So I kind of backed out, went more engineering. So as you start to think about one's career, I like engineering because it gives you a lot of options. You can pretty much enter any field afterwards. You can also go out into the world, and there is a very, in the built environment, there's a connection between, being a laptop jockey as well as going out and seeing your building built. Um, I do like the pressure of flipping a switch on at some point on a $200 million building, and it's all got to work. And
Hmm.
that, takes it, you feel useful. So, in a nutshell, I think there's a lot of careers that will be impacted slash wiped out by AI, but the built environment, especially with schools, I don't think is going to get affected for a long time. We will have human teachers. We will have places that we assemble, um, like schools. And so those aren't going to go away. They need to be maintained, they need to be built. And so if I was to say anything, think about things that you can imagine that won't get impacted. And doesn't mean it won't, but from where I'm sitting right now, I think K through 12 and schools are a great place to feel rewarded. I've gone into schools and I just ask I went into the one Dunbar again, just asked the track team, what do you think of your new school? And they just were gushing. And that, as an engineer, that's all we get, you know.
Yeah.
So
That's a great compensation package when
yeah,
teenagers gush over your work.
exactly.
That's that's a big deal. Well, Raj, it was great having you on the show today. I want to thank you for joining us. Check out his website. Again, that's SETTY.com, SETTY.com. And thanks to all of our listeners for joining us as well for this great conversation. We'll be here same time, same place next week with more Go Green Radio. Until then, have a wonderful week and do something in your life to go green.